My pleasure to introduce our keynote on the last day of the event, Dr. Maggie Levenstein, who is director of ICPSR, the Inter-University Consortium for Political and Social Research. So this organization, as you can see on the slide, is the largest curated social science data archive in the world. And under Maggie's leadership, ICPSR was actually a recipient of the 2019 National Medal for Museum and Library Service. So Maggie is a very forward-looking thinker and leader, and she leads an amazing number of really cool projects to significantly improve the capacity of data-intensive social science and behavioral science research. One of the major projects is an NSF infrastructure project called Research Data Ecosystem, which introduces new tools to support the entire research data lifecycle on the modern data platform and allows researchers to safely and securely access, connect, store, and manipulate data. So Maggie's credentials has a very, very long list. I'll just try to be short. She's co-director of the Michigan Federal Statistical Research Data Center and co-chair of the center's national network. She's also associate chair for a survey of the American Economic Association's Committee on the Status of Women in the Economics Profession. Formerly, she was president of the Business History Conference. Her research spans many important topics, such as competition and collusion, historical firm organization, and the production, dissemination, and confidentiality protection of novel and non-designed data to improve social and economic measurement. So on this, Maggie, I just don't know how you do so much. But I also want to add that Maggie is a fantastic mentor to colleagues, trainees, and to me. So I'm really happy that you are here to deliver this keynote. Let's see. Can I switch this over to my slides? So thank you very much, Jing. It has been one of the great things about being on the, I don't know what we call it, the advisory board or whatever it is to Midas, is that I've gotten to work with Jing over the last years, and it's been really great, and it's given me an opportunity to think about my work in a broader context and just meet other people. The last person who was speaking, when she said she was describing herself, and she was saying she described herself as a connector, and I thought, oh, I was at a party recently or going around the table saying and someone said, Maggie's superpower is that she connects people. So so I don't know if there's a superpower about data or economics. I am an economist by training, and you'll see that in when I'm presenting today, probably more than in a lot of the things that I do. When I present, I'm going to just lower this a little bit so I can see you all. And I also have to say, I love that you start every day with poetry. My dad is the poetry editor for a journal called Capitalism, Nature, and Society. So if anybody has poems that you'd like to have continue past this, I think that I could imagine poems from this event would be really perfect for that. So I'm here today to talk about fair data for fair data and a fair society. I won't really cover all of those things in anywhere near the depth that we'd like, but I hope that to sort of bring together what we talk about all the time at ICPSR, which is fair as in findable, accessible, interoperable, and reusable data for the meaning that we have, I think, in most of the world, right, which is about fairness. And I know that many people here are really committed to data science and using AI and other computational approaches to improve the fairness of our research and of our society. And so I'm going to talk a little bit today about the connections between those two things, where I think we're making a lot of progress, and where I think we still have work to do. I mean, there's always work to do.
I also want to begin with a land acknowledgement. The University of Michigan, as you may know, is located on the traditional territory of the Abenaki people. In 1817, the Ojibwa, the Odawa, and the Potawatomi nations made the largest single land transfer to the University of Michigan. There's a whole wonderful history on the history of land grants and higher education in the United States, and it never talks about land grants from Native American tribes, and this is a great example. This grant was offered ceremonially as a gift through the treaty at the foot of the rapids so that their children could be educated through these words of acknowledgement, through my words of acknowledgement, their contemporary and ancestral ties to the land and their contributions to this university are renewed and reaffirmed. I have to say, for years I've heard people give land acknowledgements and kind of thought, yeah, this is performative. We're not giving the land back that we took, and so what's the point? And I have to say, I think today we recognize that it is critically important to understand the ties that different people have to the land on which they lived or on which their ancestors live, and to understand how that affects us all today. So I think this is really important. I also want to acknowledge Jeanette Jackson and Alap Doshi, both are my colleagues at ICPSR, who, when I agreed to give this keynote, said, okay, they'll work with me to think about what is it that I want to say to this audience. I also want to acknowledge Allegra Fonda-Monardi, who's a graduate student at the School of Information, where I'm on the faculty, who's studying the use of AI in the production of environmental, social, and governance measures in the People's Republic of China, and those conversations with her that have been very helpful. And of course, especially since I finished this after midnight last night, none of them are responsible for anything I say today. I also should really acknowledge Jag, who I have to say has really influenced my thinking and introduced me to a lot of the way that computer scientists think about these challenges over the last few years. So, science, progress, right? I think we all, in some sense, we want to start off by acknowledging that advances in data science and artificial intelligence create enormous potential for doing more, faster, better. That means that we could do more, faster, better, and therefore we could work less and have more leisure. We could spend more time on more creative things. You've probably all seen the meme that says we want AI to do the housework so that we can do the art, not the other way around. So there's enormous potential. And even though a lot of what I'm going to talk about today are the challenges and the critiques, it's not because I'm trying to say we shouldn't take advantage of the potential, but that we need to understand how to shape the potential to deliver the things that we actually care about. The reality isn't just, linear progress until we reach the bright shining star of, scientific nirvana. It's more complicated than that. So AI isn't a lot of times I think, but people think about artificial intelligence and data science and machine learning, they think, okay, these are a set of algorithms. And actually, one of the things I often say to people is, this is not magic. It's a bunch of algorithms, right? It's a bunch of equations. That's what it is, right? And it is, it's not going to create new life or something better than humans. I actually have a very wonderful long quote that is about sort of why it is that people often think that, why it is that some people need the idea that they can create something that machines do that creates life. And in fact, we create life all the time. We know how to create life. And it doesn't require equations or computers. And we're not gonna replace that activity with machines anytime soon. But what I want to emphasize today is that data science and AI isn't just algorithms, right? That may be what I say lots of times. It's not magic, it's algorithms, it's equations. But it is not just algorithms. it's also data. And it depends acutely on the data. And I mean, I am here today, as Jing told you, because I am the director of the largest social science data archive in the world. And so an important part of my message to you today is that the quality of the output of AI or machine learning or data science, whatever it is we do, depends on the quality of the input data. As soon as I wrote this down, I wrote, and what is quality? Well, we will come back to that at the end of this talk, because actually addressing what it means we're going to talk about the quality of data a lot. The quality of output is actually, I think, even more problematic, and is what is going to remain contested, and that we need to contest going forward. So first, let me tell you a little bit more about ICPSR, because, I'm an economist who studies competition policy and firm information systems. Not really. I'm certainly not a computer scientist, right? So why is it that I'm here talking to you? So what is ICPSR? Well, ICPSR was founded in 1962 by 22 universities, including the University of Michigan. It is quite at its core, it is a collaborative, interdisciplinary organization. It is a consortium of 825 institutions located around the world who are members and who are the governing. They finance us and they run us around the world. And I would bet that almost all of you are at institutions that are members of ICPSR, whether or not you know it. If you're not, please come talk to me. We can change that. Our focus is on social and behavioral and economic and political science data, very broadly defined. We actually have a lot of health data. We have things that you might not think of as social science data, but that social sciences use to study the social world. Our current holdings include over 20,000 data studies with well over 250,000 files. So we have a lot of data, and we have over 100,000 users a year who come and get that data from us, download it, and analyze it. About 10% of our collection is restricted, almost always to protect the confidentiality of the people or the entities in the data. We also, and I think this actually gets to where I'm going, we have in terms of data quality, as Jing mentioned, we are a curated data archive. We have some what we call self-published data, but most of our data is data that has been professionally curated, and it makes it more accessible and more reusable for the general public and for data scientists. One of the things that we do is we have created a bibliography of data-related literature. It has over 110,000 publications, which are, in our system, metadata for the data set, instead of the data being metadata. The publications themselves are metadata for the data studies that we have. And these are all studies that actually use and analyze a particular data set at ICPSR. We know that this is how people find data, that they find research articles that they're of interest to, or they search topics in these publications and use that to find data that's relevant to their work or to their instruction. What does ICPSR do to support FAIR data? And again, here I'm talking about FAIR as in findable, accessible, interoperable, and reusable, though we are also committed to fairness in the more usual sense. As I say, this is just an example study homepage for one of our data sets. It's the 2012 Latino Immigrant National Election Study. I have to say I picked this study for this because it's a study that was the current director of the U.S. Census Bureau, who is the first Latino leader of the largest statistical organization in the world. He was actually involved in creating the original Latino National Election Study, and those data that was done here at Michigan, and those data are at ICPSR. So it's just an example of a data set that we had. But if you look at what's on this page, what you can see is that there's high-quality metadata, there's documentation, there's a DOI so that people can come back to the data. There are usage metrics, including how many people have looked at the page, how many people have downloaded the data. You can see the bibliography, all of the articles that we know about, and we spend a lot of time trying to figure this out, that use the data are included there. We have the metadata is exportable in multiple schemas, which is useful for librarians. It's also useful for data scientists in thinking about what is it you're ingesting and how do you ingest at scale. We have something called the Social Sciences Variables Database, which allows people to search and compare across data sets at the variable level. So these are the kinds of things that we do that allow people to understand the context, the coverage, what's missing, what's not from the data that ICPSR makes available. ICPSR is also very committed to ethical data use, and we do this in a number of ways. It used to be that ICPSR only made available anonymized data, whatever that meant. That's in quote. There was my air quotes, anonymized data. We now recognize both that there, especially when the advent of AI, there may not be any such thing as anonymized data. But also there are lots and lots of amazing things, important things that people can do with data that is easily re-identifiable or even simply identifiable by linking it to other things. So we provide tiered access to restricted data. The curation staff de-identify public use data. We also, depending on the sensitivity of the data, on the resources and the credentials of the user, we may allow a encrypted download if you have at your home location a secure place that you can do that. Or we have a virtual data enclave where we provide the compute and keep the data set in that. Those virtual data enclaves are called TREs, Trusted Research Environments, if anybody speaks British. We also have, and this is a picture of a physical data enclave, which is in the second basement in the ICPSR building, where people go into a closed room. There are no windows, but there is a beautiful mural from a local artist of the shore of Lake Michigan. So these are the different kind of physical access points that we use to make restricted data available. We also think that it is critically important that there's a social element to accessing restricted data so that people are trained in the responsible use of restricted data, and we have institutional sign-off so that there's accountability. It makes it more time-consuming for people to get access to data, but I have to say it is. I think it's really critical for respecting our responsibilities, our obligations to the people who are in the data that we have. We also, again, as part of our commitment to ethical use of data, do allow stakeholder review of restricted data access when appropriate. In general, we don't let people who create data control who accesses the data in order to promote free exchange in scientific ideas. But for data sets that are from vulnerable and populations that have been exploited in the past, particularly tribal populations, we actually do engage them in who has access to data about them. And then we do confidentiality disclosure reviews. Okay. All right. I could talk about ICPSR forever. We're also a trusted intermediary. We have a thing called SOMAR is one example of this, where we are providing access to social media data, including the metadata. If you want metadata through their API, they've shut down every other way to get access to this. You can still get to it through ICPSR's social media archive. And there's other social media data there as well if you're interested in that. So how is ICPSR using AI? I'm going to give you sort of an example of something we've done that's kind of innovative and research that we're doing that's related to that. And then I'll tell you a little bit more about what are some of the kind of maybe pedestrian ways, but I think that there are important ways that we're using AI. And this work is being done, as Jing mentioned, with support from the National Science Foundation for what we call the research data ecosystem. So ICPSR, and this is I don't know if Jag is here. This I don't know if this, yeah, there you go. Okay. This idea was Jag's idea a decade ago, I think, really came to us sort of like, okay, we should be able to use AI and I don't know if we called it AI at that point, but be using data science approaches to improve to improve the metadata, improve the data that we're curating, and to make that more efficient. So we now have a tool which has been launched, which is called Turbo Curator, and it provides recommendations to data depositors when they're getting ready to share their data, which we encourage researchers to do. And it looks at the metadata that they have and gives them recommendations for titles and summaries and keywords. And it uses ChatGPT to do this, but controls the output that they see with ICPSR's own controlled vocabulary and thesaurus of social science data, so that what they're getting is something which they feel confident using, though that it is still up to them to decide. Turbo Curator is currently available for users of Dataverse, where it has been installed by a Dataverse administrator. And I hope all of you are familiar with Dataverse. It's based at Harvard, but there are instances of it all around the world. Analysis of ChatGPT's recommendations by ICPSR's metadata librarians, working with a great team at the University of Michigan Flint, suggests that without controls, ChatGPT makes useful recommendations, but about a third of its recommendations are outside of the domain-specific thesaurus or simply incorrect. So it's useful, but even in this context, which I would not call high stakes, it really requires a human in the loop. And I would presume that a lot of what you've been thinking about are much higher stakes uses of AI in which people's, whether people get credit or get their house is targeted for a drone anyway, are much higher stakes than recommendations for metadata. But I think that we can see, looking at this, we can see both where there's benefit and what the limitations are. Like many other organizations, ICPSR is increasingly using AI in its own operations, from summarizing meetings and emails to writing code and documentation code, improving our job postings, anonymizing resumes that are submitted to us. We just received funding from the Gates Foundation to build a platform where video data on classroom instruction can be securely analyzed using AI. These are data that we have been making available securely for a long time, but not in a platform that is certainly not connected to the internet, and it is not computationally feasible to use AI there. So we're gonna be building that. We're also in the process of promulgating an ICPSR policy, which is really based on our existing policy that prohibits users from redisseminating our data. And in general, it will prohibit people from putting ICPSR data into a general purpose large language model, because these models keep everything that is fed into them that violates our redissemination. The data could appear someplace else without any sense of the provenance. All of the context that we provide in our metadata could disappear. But particularly when we're concerned that once fed into a large language model, it has the potential to re-identify data that has been anonymized, or even create the appearance of re-identification, which would cause a lot of concerns about confidentiality protection. So even if they're mistaken a lot of the time, if it looks like there's synthetic data that's been created from ICPSR data that has real names on it, it gives, it makes people feel like they have been discovered, and maybe even angry when they're discovered with errors. So we are working on controlled ways, as with the educational video data, to let users safely take advantage of AI tools, but this requires more research. So I said in the beginning, the data matters, right? So how does the data matter? I think we all sort of know this at this point, but it's important to come back to this. Having lots of data is not enough, right? The data can still have challenges in terms of what I might think of as what I was a representativeness, or what I call representation, also in terms of reality or the context. So the importance of representativeness, I think, is the thing that is, at least as an economist, is the most intuitive. We want the underlying, right? We want the data to reflect the underlying population about which one is going to make an inference. And that's a fairly well understood problem. We can reweight data to reflect the population if we have baseline data and if we have appropriate knowledge mapping from the population to the data. So that requires both statistical knowledge and it requires domain knowledge, and I'm going to come back to that. So it includes a model of the relationship between the underlying population and the data that you have in front of you. This is, for example, a central challenge for polling data today. We have a lot of polling data, more maybe than we want, but we don't know the relationship between the polling data that's being collected and the population of people who are actually going to vote. Because the relationship between those two variables has changed and is uncertain. The domain experts themselves have uncertainty about the model between the two. So we need domain experts to help us understand the relationship between the data that we're looking at and the population. And we need that, and we would like that data. We would like to understand how representative it is or is not of the underlying population, so that we can correct that in our models as necessary. Representation is different, and by representation, I have to say, I don't mean, this is where I sound like an economist, I don't mean like, do I feel like I'm there? I mean, because that's important in a lot of things, though, because we often don't see what's inside the black box of these models. It's maybe less important, the representation in that sense, but it is incredibly important that the character of interest is in the data at all. Or is it there enough that the AI process doesn't hide it? Or perhaps even intentionally hide it because the number of such people or such entities is so small that we need to protect their confidentiality, and we do that by disappearing them, right? So if you're not represented in a way that that covers the space of the domain enough that you can be protected, then whatever that algorithm is not going to capture who you are and what your relationship is to the questions at hand. Sometimes, so when I talked about reality, I was kind of on an R thing until I wasn't. But anyway, is that, as I think we all know, sometimes our models are estimated on representative data that reflects the reality that we live in a very unequal and unfair society. And if we simply standardize data and embrace algorithms as a way to do this, then what we're doing is reifying and obscuring the existing problems. So sometimes we need to understand the domain that we're studying, to understand the reality, to say, well, yes, you've estimated correctly the relationship between these things, but that doesn't tell you why that's the case. And it doesn't tell you that is necessarily the way it needs to be or should be, and in fact, how we might want to intervene to change that. And finally, lots and lots of times, increasingly, data is simply decontextualized, and the metadata, the kinds of metadata that I've been talking about, really include things about provenance, about methods, about the representations and the representativeness of the data. And this metadata provides the context that improves the quality of the output of AI and data science. So what we need is both high-quality data and domain knowledge. So this is This is Maggie entertaining herself. That's Jane Goodall. And that is domain knowledge at its most intimate. So interdisciplinary collaborations are critical to high-quality data science. I say this from the perspective of ICPSR, which is an organization that was built on interdisciplinarity, but I think it's actually what is exciting about so much of what goes on in data science today is that it really is bringing together people who are doing things that are with new and cutting edge methods, but bring them together with people who understand underlying data and understand the theory and the problems, so that we're not either reinventing the wheel or discovering things that are not true. So interdisciplinary collaborations are critical. There's a prevalent idea. I sat in one of these conferences where you're supposed to write the paper right while you're there, and arguing with people of saying, we don't need to understand institutions, we don't need to understand theory, we don't need to have any previous knowledge of the domain as long as we have enough data. I hope no one in this room believes that, but I don't know, so I got to tell you, no. This misses that understanding isn't just what the questions to ask of the data, what are the questions we should be asking, but that the data itself requires domain knowledge. Both high-quality data and domain specificity are systematically undervalued, even by those who understand that there are serious equity and fairness issues that are raised when data is flawed in these ways. This is particularly problematic because there's a lack of transparency. We often don't even see the data that's feeding into certainly commercial AI. And then those data science and AI tools are built into the workflows of many other processes. So problems that might be identified in a domain-based application are invisible to the data scientists and to the ultimate users. We can improve the quality of our AI and our data science and reduce its negative impact if we increase transparency and if we pay attention to the quality of the data, which means often consulting people with domain knowledge, stakeholders with domain knowledge, so we understand the quality of the data that we're using. So lack of transparency is a challenge for the reasons that I've talked about. We might not know whether the data are representative. We might not know who's represented in them. We might not understand the context in which they were generated and therefore understand what it is we're seeing. This is an invisibility cloak. So anyway, can I say, I was having fun. So lack of transparency is a challenge, and I think it's an ongoing challenge. Black boxes are not good either for the legitimacy of science, and I don't think you can live, at least in the United States or on the planet today, and not realize that this is an enormous challenge. That if people don't feel like that, if people don't believe that at least people who they trust can make sense of and understand what's going on in science, they don't accept it, and it actually makes scientific progress harder. But it's also that having a lack of transparency also limits scientific progress. Even people who trust science, if you like, and trust AI can't participate and improve on it and enhance it if they can't actually see what's going on. So lack of transparency highlights a pretty deep challenge for using general purpose LLM for science, and that is that they are neither transparent nor reproducible. If people do not understand what is generating a result, they can't contribute to incremental learning in science. We already have these, as I mentioned, severe challenges with legitimacy of science. Creating more magical black boxes doesn't develop people's ability to think scientifically. It does not allow people to think critically. In fact, it encourages people to tell people, we think you should think critically, except that when we give you a black box, that we tell you is is true, right? We have to be able to reproduce, to tinker with data as well as with models, and to understand why something is the case if AI is to be useful to science. One of the things, actually, in sort of thinking about explainability, is that I think that there's a tendency to sort of, and we all do this, to kind of come up with stories that explain the result that may or not actually be what reflect a theoretical model, or even necessarily reflect what's driving the underlying data. And trusting ourselves to be willing to be honest and to explore what's in our results and what's driving our results, I think is really critical to moving forward. Okay. All right. So to have transparency be meaningful, we actually also need data literacy. We need data literacy for workforce development. We need data literacy for educated consumers so that they know when they got turned down for this credit card or this home loan or whatever it is, that they understand what's going on. We also need it, most importantly, for empowered citizens. The flip side to the lack of transparency, the antidote to transparency, is increased data literacy. It's critical not just among academics but in the broader community. Data science and AI should be empowering people, but given how most Americans, at least, feel about math, this is going to take some effort. If we want AI to have a positive impact on our society, we have to make a serious commitment, a sort of a Sputnik-level commitment to broad and deep increases in data literacy. We need to let people know that everyone can do data-based math, and we need to build and deploy curricula that are data-driven and have fun activities using concrete data about real people and their lives throughout our educational system, beginning with K-12 and pre-K and going into lifelong learning. We need to train adults, including adults who are currently convinced that they aren't good at math, so that they are empowered not just to join the AI for course and not just to be educated consumers, but so that they can be informed and empowered citizens who have the ability and the sense of themselves to make decisions, not just to use AI but to regulate AI. So I've been talking a lot about problems. AI is risky, but we have tools. High stakes use cases of AI require that we have fair data for fair AI. We have some great tools, including the nutritional labels that Jag and his colleagues have worked on, various other kinds of tools. I listed one here, just increasing checklists of what it means to be AI ready. If you look at the executive order from the president and President Biden and the Office Manager and Budget, they're all about different parts of the federal government creating checklists to make sure that their data are AI ready. So I'm not saying that we have solved this by any stretch of the imagination, but I think that we have people who are working on this and who are making a lot of progress. And we need to continue that work and to encourage it. But I would say we also need not just more tools. People need more than knowledge, right? Transparency is not necessarily accountability. People need power, and it's actually you can. And lots of the times we talk about making the data more transparent, giving people more explainability about. But we also need to have about what an algorithm is doing. But we also need to give them a mechanism and the knowledge to be able to respond and intervene when their lives are being impacted by this. So another challenge that is necessary for fair AI is that we need to think about not just individual characteristics, which is what we usually are doing in most of these things, but understanding social structures, and that people respond to incentives and that people exist in society. So this is the wave icon. And what I like about the wave icon in this context is that one of the things that we know is that individuals, when you give them information, you tell them that they're being judged on something, they're going to respond, and they may not respond in exactly the way that you want. In economics, we call this the Lucas critique, so that if you tell people that there's going to be inflation, they will raise prices, and that it creates inflation, and they will change, they will respond to government policies. So we know that this is true. We know this is true in economics, and quite generally, we know this is true for driving behavior. We need to think about that as well, but also we need to understand that people exist in society. So an example that came up, I don't know, last week or so, was that Nevada schools were using AI models to predict which kids were at risk. I don't know if other people have heard this story, and have the funding follow the kids that were at risk. And so there was debate because it changed who was getting which schools and which kids, where the funding was going. It was a smaller number of kids getting more money, so there was all the discussion about that. But the discussion missed that kids don't live on a Robinson Crusoe island, right? What they do affects others, and what others do affects them, whether they're around other kids that are hungry matters, whether there are jobs to look forward to matters. The models that focus only on individuals and their characteristics, and maybe even even if they control for billions of other things, including sort of social context, misses that people are actors with agency in a society which may have more or less opportunity, and that may affect whether a kid is at risk as much as anything about that kid's characteristics. So we want to use these things, but we also want to understand their limitations for addressing what are fundamentally social challenges. I had to say another example that comes up, we talked about this, where someone is standing on this stage, is Raj Chetty, who's done a lot of work on inequality. And Shannon, he's an economist at Harvard, does amazing work on inequality and shows that, the chances that kids are upwardly mobile depends on the neighborhood in which they live. And so people are like, oh, well, our social policies should be to hand out bus tickets so that people move from one neighborhood to another. Well, neighborhoods aren't just people. They're communities, and they're buildings, and they're spaces. And what happens to those spaces when some of those people leave and some don't, or when everybody leaves and it turns into, that's actually not how you build a fair and just society. Isn't by giving everybody the option to opt out and take care of themselves. And we need to think about that as we think about the kinds of recommendations and the kinds of solutions that this way of thinking pushes us toward. One last thing, is AI fit for use? We, as I said, we're using AI in a bunch of really cool, fun ways at ICPSR, giving people recommendations about their keywords, and it shortens the time that curators need to use, and it gives them, they come up with better things. But is that we also have to think about the costs, and this is 3 Mile Island, and the costs to whether it's increased carbon or increased nuclear waste, are things that we need to think about, and we need to make sure that those costs are being internalized as we increase the use of these technologies, which again have enormous potential, but are going to cause other kinds of challenges if we're not thinking carefully about this. So the last thing I want to say, and this is the I really am an economist, is just thinking about these things is not enough. Just teaching people about how to use ethical, high-quality data, using ethical practices, being ethical is actually not enough. I believe everybody in this room has goodness in their heart. I actually believe that about pretty much everybody. And I think that we're all, and what I think we benefit from developing and sharing and teaching people about the tools that allow us to address these challenges. And those are absolutely necessary, but they're not sufficient. And this gets back to the question about quality that we started about. So what does it mean? We sort of have this idea that if we do better, if we have better data, if we have better algorithms, if we have better trained people who are more ethical and are good, we will get higher quality data, and then we'll get higher quality output from our data science, and then that's what people will use. Well, so this is a classic example, Betamax versus VHS tapes, both of which, of course, are now obsolete. But VHS beat out Betamax, even though all the technologists certainly agreed that Betamax was a much better technology. This is taught in a gazillion business school classes, but it is also captures that technological change doesn't happen, that technological adoption doesn't happen just because something is technologically better, because it's higher quality, certainly higher quality from a scientist's point of view. The AI tools are increasingly embedded in other workflows. They're embedded in a supply chain in which a firm sells something to somebody who uses it for something else, right? And the competition between those firms is what's going to determine which technologies get adopted. And unless the rules of competition are set so that they have an incentive, that they are rewarded or make it impossible for them to compete over using cheap, dirty energy and cheap, dirty data, that may well be the thing that they make the most money doing. And it may be perfectly reasonable for them to do so. And it may cause heartburn for some of their employees, but it is extremely hard. And it is not reasonable for us to expect that companies are going to adopt approaches that embrace fairness and embrace equity and embrace what we might define as higher quality if they are not, let us say, incentivized to do so. There are a number of ways that you can incentivize them. President Biden's executive order on artificial intelligence actually charges the Federal Trade Commission with ensuring competition in AI and ensuring that there's entry so that new firms can enter, which is important for innovation, but again, does not ensure that what they will be competing over is fairer AI and fairer AI output. Regulation, government procurement by large organizations like the University of Michigan must require that tech firms compete to provide more ethical and less biased AI output. Because that is what will lead them to adopt the great tools that the community is developing to solve these challenges and to make AI something which contributes to human well-being and the planet's well-being rather than undermines it. So thank you all very much. Thank you. Well, yeah, I'm happy to take questions.
I'm coming. You can meet me halfway. Come on.
We're all getting our steps.
Thank you for that great talk. And towards the end, you had a little plug-in for how important it is to go all the way back to K-12. My name is Padusri Sher. I have led the task force for the first ever data science standards of learning and a high school class that was created after the standards were developed in the state of Virginia, which is now being taught in 120 schools, which is going to produce 5,000 students. So one of the things I wanted to also say is how AI, not only in terms of curriculum, but also helping with efficiency. So at Colorado Springs, just recently, they created an AI tool that cut 45 bus routes, created $8 million because of that. And the most importantly, 99% on arrival time, the schools and all this stuff. So schools are already innovating these types of things, not only in the education space, but also efficiency space also. So, I'm just curious, you were talking about industry and government. I'm just thinking K-12 space, community college space, all of them want to innovate. But the challenge is they're not talking to each other. And one of the biggest things, so as a higher ed faculty member at George Mason University, I'm able to see K-12 to community colleges but then each one of them is doing their own AI initiatives. So any comments on how do you actually communicate across and collaborate between? That would be great. Thank you.
So a couple things. The one thing I'm going to say about the K-12 space and AI that I think is really important and that would actually, I think, begin to address one of the challenges that you're talking about, the communication, though it's probably not what you were thinking about. I mean, and that is that a lot of school districts now are contracting with firms to use online platforms to collect data to provide educational materials to kids and to parents and to manage paying for lunch and all these things, and the information that is in those data systems belongs to the companies, not to the schools. And it makes it really hard for schools to participate in collaborative research, innovative things, which might set their priorities first. So it might be that, for example, a school district might want to reduce the number of buses and save money, but it also might want to make sure that no kindergartner is on a bus for longer than 20 minutes because, right, that might be a priority. And they might want to be able to customize things and to talk to other school districts about how they've done this. And that's incredibly hard to do when they do not own their own. They don't own the information about their own technology. That's true about the learning platforms that they use as well, right? That those platforms that are often owned by publishing companies these days own the data, and it has limited activity. I can tell you we are sponsoring. We've been developing a community of practice at ICPSR, but for about 20 different research teams all across the country who are working on building new AI-driven tools for mostly for the K-12 space, some in higher ed, that's funded by the National Science Foundation and several of the big private foundations that are now sending their money through NSF with the hopes of creating, several of these projects are hoping to create research infrastructures that are platforms for sharing data across educational institutions. But that is, as I said, it's much harder to do in K-12 than in higher ed. Though a shout out to Michigan and to, what do we call you can get data on the Michigan, a lot of data on Michigan students at ICPSR. You can get it through something which we call College and Beyond too, where it's linked to a lot of other data. But there's also a lot of, does anybody remember the name of, it's got a U in it. It's, everybody makes up words. No, IPMS is different. So it's a consortium of universities that are sharing their administrative and digital trace data on the students' activities. Unizon, thank you very much. I know. See, I have a letter right. My kids call my phone my brain. If I don't have it, I don't remember anything. So there are higher education institutions which are engaged in making their data available, both for improving pedagogy and improving other aspects of learning. But those data sharing is a great way to encourage collaboration because everybody has some stake in the game. They feel like they are represented, and they learn, but they're getting something which is beyond just them. So that's one strategy. But not the only one.
Hi, I kind of like to follow up on that. Sorry, behind. I wonder how much of that issue is just related to people who would like, or organizations who would like to get access to data, not using the market power that they have to get it. And the reason I ask that is it's a big problem in healthcare too. So we work with a lot of health plans, with a lot of employers, with a lot of provider agencies. And when employers work with health plans to help them design, provider networks and arrange for insurance benefits and that sort of stuff, a standard clause in the insurance company contract that they open up with is, we own the data. Might be data about your employees and insurance, but we own it. But at least the biggest companies out there basically say, no, you don't. It's our data. And if you want our business, that's not OSHA. Most other companies don't have that kind of market power. I'm sure individually school districts don't have that kind of market power. But maybe, the state of Michigan or the state of wherever on behalf of the school districts might have enough market power either to say we own the data, or sure, you own the data, or we have perpetual license to use it the way you see it. Have you seen any of that, or is that just me sort of dreaming about maybe a potential solution there?
So I would say two things. One is, I think this is all about market power. That's kind of where I ended, because I do think that that's what this is about. It is, data is valuable, and companies that can keep it and use it and monetize it are doing that. I think that we do see in Europe with the Digital Services Act, and I expect, if it hasn't already passed, similar legislation is going to pass in the UK, that requires platform data to be available for research and scientific purposes. And there is no reason, except that we all know why. We don't pass anything in Congress anymore, but it is completely feasible for the United States to mandate data access for public purposes, for health, for educational purposes, to data that is held by platform companies. And if we actually want to make progress in both improving the data science and improving the impact of data science, I think it is critical that that access be available. That would also improve competitiveness, because it might allow other players, small firms, to do things that are creative that a large firm might not be doing. But more importantly, it gives the people, the communities, the organizations access to data about themselves. Obviously, someone didn't like what I was saying. Access to data about themselves, because they may have different priorities. They may want to focus on a different objective than the companies that own that data. So, I have a loud voice. Is there anybody who can't hear me? Yeah. Oh, all right.
Now I heard a Diane voice. Other questions?
Hi there. I had a question. Thank you for the great talk. My question is, what do you think is the responsibility of your higher education institutions, such as universities, about sharing data within the university and being universities? So I noticed that there could often be like these little silos of data within an institution, and oftentimes it's really difficult for people to get access to that data or even know that data exists.
So do you have any specific strategies?
So ICPSR exists to address that. I mean, if I could give you a whole talk on why data sharing is and data access is important and is feasible, and is actually good for individual researchers, is such a compatible, as we would say. It is important. You're not really advancing knowledge if you create data that only you can access and nobody can, look at it and again, make progress on the knowledge that you've created from that data. If that's the end of it, then what you've contributed is much more limited. What we know from ICPSR's 62 years of making data available and keeping track of our bibliography is that when people share data, more people read their publications, more people cite their publications, your research impact increases in ways that you can measure and put on your annual report and your promotion form. So caring data is good for you as well as good for science. And is it feasible? So there are a couple things I'd say. It is to make data useful to share does require some investment. We provide a lot of guidance and tools to researchers to help people to collect and manage their data in ways that will make it easier and less cumbersome to share. But, I have data on my, on some floppy disk someplace that, I don't remember where I got it, what it means. And so I understand the challenge, but it means that there's, again, that's a real loss of knowledge. So we had tools to do that. Those tools are often domain specific. So we provide, what we provided for social behavioral sciences, some of those are very general, but there are other things that are specific to particular domains. So we encourage people to look to domain repositories who will have high knowledge about the appropriate metadata, about the appropriate standards, and the appropriate places to share their data. I have to say, the University of Michigan, its own policy. The University of Michigan has done a great job of sharing data for many years, including shared data and making accessible data about itself. It makes the data on our health system is available at least for Michigan researchers outside of the health system to use. But our official policy says the data has to stay at Michigan. And oftentimes it might be that the data should go someplace else, right? If you're, collecting MRI data, then you should put your data in a repository that specializes in the brain repository, right? I mean, that's imaging. So this is the Nature data, I believe, actually has a whole list of domain repositories. They also list general purpose repositories, some of which are very good. But I encourage people to think about domain repositories because you do get more guidance and more specificity to the metadata you're creating, and there's more discoverability, right? You want people to be able to find your data. There are very general purpose tools like Google's data search, and we've worked with them so that if you search for data, using things like that, you will discover ICPSR data. Any repository that's using best practice metadata standards will be discoverable through a search engine like that. But that's what I would say. Yeah.
Great, thank you. I think we're out of time, unfortunately. But thank you. Another round of applause for